All right, so welcome also on my behalf. I'm Jani Lammi and I'm coming from Nokia. And actually my presentation is related for this Nokia RAN Intelligent Controller. But before that one, I would like to show you a couple of things which are actually driving us to use this RAN Intelligent Controller. So why on earth we are bringing another network element in there. And also very important if we are thinking this whole edge transformation. Actually we were hearing that already in a downstairs when there was a keynote session when they were discussing what is actually happening there, what kind of traffic growth there is, and what needs to be done. But I will recap that shortly, and then we will see how this RAN Intelligent Controller is actually working and what kind of use cases we are having already there. And then I will show you one demo, what we have done with one of our customer in one country. I'm not allowed to say where, but what kind of results we were seeing from there. But like said, so the topic is this RAN Intelligent Controller for these near real-time use cases. And when I'm talking about these near real-time use cases, so it means that, of course, a lot of things can be done already today. But if we are having this kind of monolithic networks where we are making these very strict rules, so actually it's not flexible at all. And we know that this traffic is changing all the time, so people are moving and so forth. So we need to be flexible and we need to be able to bring these certain actions in a network on real time or near real time. So I guess everybody are going to show this type of picture today, and maybe a couple of things here. So the traffic growth is quite hockey stick, as we were hearing in downstairs, and as we can see here. So this has been taken from this Omdia cellular data traffic forecast, and in there they have been estimating how much this cellular data traffic is growing from 2021 up to 26. And we can see that this kind of compound annual growth rate is around 30%. Of course, there is a little bit differences in different areas, but in overall, so the growth is around 30%. And of course, there is a multiple reasons. Of course, we are now getting these new radio technologies. So there is now 5G. There is this millimeter wave technology that is capable to handle quite outstanding amount of data. But of course, the network or these radio networks are not generating that data. There has to be always some kind of applications. And when there is an application, so of course, then this traffic growth is quite huge. And if we think this kind of traffic growth here, so today, the most of the networks are having these bare metal baseband units, and we are having quite this kind of statistic network all over the places. There is already some customers who are starting to do this kind of proof of concepts with the Cloud RAN and so forth, but I would say that we are not yet there. So there is one CTO from one tier one customer in US who said that they are going for this Cloud RAN when they are able to meet 3P. What does it mean? So it means that the performance needs to be equal or better what that is in today's network. That's quite clear. So of course we cannot bring there a network that is not performing. Then the second one is this power consumption. So it cannot be higher than this existing bare metal solution. And then, of course, the third one is price. So when we are able to meet all these 3Ps, then they said that they are going to do this kind of massive rollout in the US for this Cloud RAN. And of course, today, bare metal baseband units are, of course, much cheaper because we can really optimize all these system on chip in there. But however, these x86 CPUs are developing all the time, and more power are getting there. So of course, that is driving for direction that in some day we can really to do this kind of rollouts using this x86 based baseband units. And then of course the power consumption, so it has been completely optimized in this bare metal solution what we are using today, but in the future I believe that we are able to get this power consumption in the same level what that is in today's solution. And then of course the cost is a big driver, so that we need to find out how we are going to do it, but we will do it. So if we are looking at these key pillars for this mobile edge transformation, so of course run cloudification, so that's clear, we are going there. So we need to build a network which are flexible and elastic, that we are able to bring this needed performance in right locations. And of course, that is then bringing this kind of decomposed run architecture. We can take these certain x86 based servers, we can install our VDU, VCU in there, we can use different cache layers in there, and in that way serve those different customer segments in a best possible way. So we can decide, are we having this kind of centralized cloud run or distributed cloud run or something between of that. But that's not all. Of course, we need to bring this kind of network slicing as well in there, because typically CSP customers are already having all these RF assets all over the places. And now, if we want to really bring this quality of experience or quality of service for certain enterprise users or these kind of closed user groups, so then, of course, this end-to-end network slicing is a key for that one. And then, we are coming for today's topic. So, of course, this CI/CD was mentioned in a downstairs. So, of course, this cloudification is bringing this kind of CI/CD software deliveries, it's bringing this kind of automation in there and so forth. So actually I believe that these are the key things when we are starting to cloudify these networks. And then we are having these application services and also this programmability in there. And it means that now we have been using this monolithic bare metal baseband units in those towers and so forth. But now, when we are bringing there these x86 or ARM-based servers, we can bring there more. We don't need to run only this cloud or run software in there. So we can bring there different applications which requires this low latency. And then, of course, how we are able to cope this whole huge traffic growth, what these applications are then bringing for this network. So then, of course, we need to be able to bring there some intelligent. And this previous presentation was related for this energy saving. But of course, now this RAN intelligent controller can bring there more. It can bring there a multiple different type of use cases. And today I will introduce two. And I'm having results from real network. And we can see that actually the results are quite outstanding. So a lot of savings to our CSP customers. So let's go there. So first, I would like to show you what is this RAN intelligent controller. So it's a completely new network element specified by this O-RAN Alliance, this work group 3. And it's connecting our baseband unit using this E2 interface. Now in the first phase, when the radios are not supporting yet this E2 interface, because it's a new one, so we are using this DCAP, and I believe that in lab here, currently we are having this DCAP interface there, but actually during autumn timeframe, we are bringing this real E2 interface also for those baseband units. So actually, between of this E2 interface, we are able to give and get some information. And then on top of this near real-time RAN intelligent controller, we are having these open APIs. And those are specified. So somebody who can build some kind of X applications, like you were mentioning this energy saving, so I was looking that it was quite actually complex formulas what you had in there, but anyway, so now third-party companies can start to bring functionalities in this near real-time RAN intelligent controller that is actually handling this radio control plane. That is a completely new thing. So before that one, there was Nokia's network, there was an Ericsson networks and so forth, and we were keeping everything in our side. But now actually you can start to bring there some intelligent and really build these kind of X applications which are then controlling these radio resources. And then of course there is this SMO layer. So in there we can have this non-real-time RAN intelligent controller. But if we are having this kind of situations that you are having, for example, this kind of group of beams in a massive MIMO and people are moving there, so of course we cannot do that, okay, maybe tomorrow we are changing something in there, so we need to do that almost near real time. So that's why this near real-time rig is capable to do these decisions almost immediately. And one other example what I'm going to show today is this advanced traffic steering. And of course, it might be that the subscribers are not located equally on these different radio layers. And might be that the operator is having just 5 megahertz or 20 megahertz of band 1. And the most of the subscribers are just hanging there. And then they're having these other layers where they have maybe 40 megahertz of bandwidth, or maybe this millimeter wave spectrum in the future, so 800 megahertz. So of course, then to really get this best out of the network, we can decide to move those subscribers for different frequency layer or different technologies using this near real-time RAN intelligent controller. Here we are having a couple of examples what we can do. Of course, it's not only these use cases what these application developers can do, but we can get an information, almost all information what is happening in a radio site, and then we are having also this information about the subscriptions and so forth. So we can combine actually quite nice punch of data and then make this kind of decisions. So we are having this AI ML in there, and based on that one, we can make these decisions almost in real time. However, of course, if we are having this kind of advanced traffic steering or cell anomaly detection or this one, so we need to teach, of course, these machine learning algorithms that they are able to then handle this network properly. But of course, that happens automatically because we are collecting the data all the time there. So there is this kind of policy enforcement. So if we wanted to force some subscribers from LTE layer to 5G, it can be done. If we want to do this kind of mobility optimization or this energy consumption optimization, so it can be done, and many other these different type of use cases can be done using this near real-time rig. And of course, this E2 interface is specified. So it means that in theory at least, it should work with Nokia radio, Ericsson radio, and so forth, as long as they are having this standardized E2 interface in there. So let's have a look then, a couple of these kind of results. And now I have to say that don't take these too seriously, because those might be different network by network, depending what kind of profiles you are having in there, what kind of layers you are having in there. But these are the real numbers measured from our customer networks. So the first one, the use case is this kind of advanced traffic steering, and it's pretty simple actually. So here we can see that we are having this band 1 and band 3, so 2100 and 1800 LTE layers. And we can see that the 2 subscribers are located in band 3 and plenty of subscribers in band 1. And now, depending how much frequency bands you are having in there, so 20 megahertz or 15 megahertz or whatever, but of course that can be then as a one parameter in this RAN intelligent controller. So it's measuring all the time how these subscribers are located in this network. And then, based on these measurements and this machine learning algorithm, this RAN intelligent controller is asking these subscribers to distribute equally for these different frequency layers. And we have seen quite outstanding results, so 19% better end user throughput in our customer network. That's really huge number. And of course, it doesn't need to be just these kind of LTE bands. So it could be, for example, LTE and 5G, or then it can be the sub-6 and millimeter wave and so forth. So then you can make actually these use cases for our CSP customers. Then another one, I will show you later one demo out of this one, but it's this kind of massive MIMO beamforming optimization or group of beam optimization, so horrible name, but nowadays in these new 5G radios we are having these kind of beams. So these kind of very thin beams which are then distributed for this network. So we might have 32 or 64 TRX in one radio sending these beams all over the places. But unfortunately, there is always this kind of default or static beam setup. And of course, that is not correlating at all how the peoples are moving in this network. So it might be that if we are having a railway station here, and the peoples are commuting there in the morning, and suddenly they are in their offices. So you don't need to have this kind of coverage or performance on that area. And now, again, we can collect this information and using these machine learning algorithms in our RAN intelligent controller, and then actually start to steer these beams. So we can decide that, okay, maybe in a certain area this performance is really weak because the signaling strength does not exist or is really weak in there. So then we are actually modifying this group of beams in a way that we are making these thinner beams in a location where the subscribers are located. And in that way, we have seen that 5 dB, I don't know how radio persons you are, but 5 dB in this kind of coverage perspective, it's huge. So it's bringing outstanding benefit for the operators. And these are just the two examples. So we can bring there more these type of intelligent in our customer networks by using these open APIs, what we are having in this near real-time RAN intelligent controller, and really started to think, what are these hurdles what our customers, our CSP customers are having? So energy consumption, I know that it's a hurdle number one, at least in this point. So electricity price is getting higher and higher all the time, but there is more. So really taking everything out of the network, because also these frequencies are expensive. So we can do that one. Then we can also bring these intelligent for these beams, so really bringing this coverage in there where they don't have, so you don't need to install a new radio there, because we are just optimizing a network and using the same radio what you are having already. So a lot of benefits. And let me show, I hope that my computer is able to show this one, because it's the video, but let me explain here. So, okay, this is not so busy area, so it's in Finland, but you can see that on top of this building, there is a massive MIMO radio. And now they are having these kind of beams, so it seems that it's ATRX. And it's having this kind of default setup. So no intelligent at all. So just beams there. And might be that there is these kind of areas. I don't know, is there anybody picking some mushrooms or berries in this forest, but most probably not. So why we are creating this 5G performance in there. But then they're having these certain residential areas, and for sure people would like to use 5G data in there, but might be that actually they are somewhere between of these beams, and actually they don't have this signaling strength at all. And then let's see what happens. Oh, okay, so it's flying around there. So you can see that the equal beams in there. And this is based on real data, but it has been animated in this way. Okay, so you can see that good signaling strength here, but here actually barely you can get any service. And that is the problem, because otherwise if you would like to bring this kind of performance in there, so you would need to build a new radio site. And of course that is then taking a lot of energy and so forth. But now this group of beam optimization, so we can take these kind of learnings from the radio using this machine learning algorithm in this near real-time RAN intelligent controller, and then we are starting to optimize these different beams. So instead of having these very wide beams in all of the places, we are making these much narrow beams which are then reaching much longer. And actually in that way we are able to serve those subscribers who are located on those locations where you need to have this radio capacity. And before this RAN intelligent controller, maybe only telecom vendor optimization service guys were able to do this kind of nice favor for our customers. But now these third-party X-application developers can start to do this type of applications for our CSP customers. And it's showing that, okay, I don't know if it's showing anything because it's not running too smoothly, but okay, I will stop it here, this one, but it means that instead of building a new network, so we can bring a lot of intelligence now for existing network. And it doesn't need to be this kind of cloud run. So we can take this kind of step already today. So in our lab in downstairs, there is already this RAN intelligent controller that is capable to handle this 4G and 5G. And there is this open APIs. And we can take these third-party X-application developers here, and then they can start to develop these certain use cases for these CSP customers. So if I'm trying to summarize a little bit this one, so then we are having some time to discuss here. But of course, this compound annual growth rate is quite huge in this cellular data. And there is, of course, multiple drivers. So now these new radio technologies like 5G and millimeter wave radios are bringing much more bandwidth in a network. However, it requires always some kind of application that is actually generating that traffic. There is now this fixed wireless access that is coming for this millimeter wave spectrum and so forth. So I'm pretty sure that the numbers, what we are seeing here, so if we are looking those in 2030, so those are much bigger. And it means that we cannot handle this type of traffic anymore. using this bare metal based solutions what we are having today. Of course, those radio units, so those RF units what you can see on those telecom towers, so for sure those can handle that traffic. But then when we go for this edge cloud, so is our baseband units able to handle those anymore? Can we bring there something more intelligent in that area to actually handling that traffic in there? And then, of course, there is this transformation in this cell edge that is happening already today. So this RAN intelligent controller is one example. So it's specified by this O-RAN Alliance, this work package 3. And there is these open APIs that we can start to bring this kind of intelligent and programmability in this cell edge. And then, of course, what that is then enabling, so of course, we saw those two examples. So 19% better end user throughput. So actually, that's quite amazing. And then 5% better coverage. So if we need to do that in some other way, bringing there more base stations or do this kind of network optimization manually, actually it's really expensive. And now we are having a capability to bring there this kind of machine learning algorithms in a cell edge which are doing that automatically. So that was my last slide, and now I'm more than happy to discuss with you because I have been just talking here now. So any questions from your side? Yeah?
Maybe one short question. I mean, do you have some kind of program at Nokia or something like that, kind of that to support this kind of third-party app developers? I mean, for your rig?
Maybe Joachim.
Yeah, so this is in the context of this laboratory. Yeah. So we are trying to set up an ecosystem of Mix&Test developers. We have them communicated to community that we will deploy when they can do their work, get access to the rig capabilities, and start to develop the results. This is actually for because this is the purpose of our activity in this lab.
Yeah. So this lab is not only for us, so it's all of you. Yes. Yep. Yep.
So maybe can I give you this? So are you guys having your own rig implementation or are you using ONF implementation?
It's our own rig implementation.
Yep.
So if I'm a third party developer and let's say if I want to develop an Excel for somebody else, then how do I do the implementation?
But more or less the same APIs are used. Yes.
Yeah, and the Nokia rig is actually based on an open source project that we're having in the O-RAN software platform.
Yep. More questions? Yep.
So the 19% and 5 gain, that was based on the Nokia implementation with AirScale, Nokia radios.
Yes. Yes.
How would that picture potentially change if you have a multi-vendor environment?
Well, it's a good question. We don't know yet because this E2 interface is not available in radios. So like I said in the beginning, so this E2 interface that is, let me reverse back a couple of slides here. So this one here. So either we don't have it. Okay, we are having that already in our test labs in Nokia, but we are bringing that during an autumn to our customers. And this is the problem because if we are looking these other vendor radios, I'm not mentioning any vendor name, but also they don't have this E2 interface available yet. It's coming, but it's not available yet, so I cannot answer to your question because we haven't tested that yet. But in theory, it should work also with them. Yep.
You mentioned the newer implementation, but what is the status of the non-real-time? You mentioned that you
We are actually having this maybe Jonne, you know better, but we are having this Nokia Ethernet. We are having this Nokia SON Ethernet there, where we are having this kind of non-real-time capabilities as well. So more or less, all these different kind of use cases can be also implemented there. However, the problem is that it's really non-real time. And if we are having these kind of use cases, what I was showing here, so this situation is changing all the time. And if we are doing these decisions based on yesterday data, so maybe it's a really stupid decision. And the same thing here. So if we are not able to control this group of beams or maybe whatever in there on real time, so the situation might have changed.
The non-real-time rig defines scenario for maybe not milliseconds but seconds. I guess that's quite good because it's quick usage. You can do this at the seconds interval, not milliseconds.
Not milliseconds for sure, yeah. But typically, these kind of non-real-time rig, we have seen that the decisions are made based on some minutes or hours and so forth. Yep.
I mean, before, in 4G, also in 3G, there were some features which are implemented in the base station.
Mm-hmm.
Now, this near real-time rig substituting these some features.
No, well, actually, it's not replacing these kind of 3G features at all, because this is not supporting a 3G. But now we can bring the similar type of capabilities also in there, what we had already earlier time there.
But why? What I don't understand is why not to put these some features again, similar solutions that you optimize intelligently by learning the network and the functions.
Actually, yes, we can put those in there, in this non-real-time rig or this kind of SMO layer. But then, if you need to do this kind of really fast decisions, so then of course it's not possible. And then of course, are you able to control this right area with that one? Because might be that especially this self-organizing network, so it's more or less this kind of network level.
Right.
And of course might be that the decision needs to be made on this G0 bin level.
And where that the real-time rig sitting in the network, is it in a radio unit?
It's not radio unit, so maybe we can go for the downstairs to see that, but in Nokia we are having this airframe open edge x86 based servers, and of course we can run there these other workflows. So for example, we can bring there this VDU VCU, for example, if needed, and of course this L1 accelerator as well. We can bring there also another, so more or less this is located in this kind of far edge or edge side, depending a little bit of this network architecture.
So it can cover city or...
Yep. Yes. Yes.
So what you just said is you are federating the rig at the virtual CU level, or is it at the base station?
Well, I would say that this rig can locate it. Okay, let me go back here. So because it's just an x86 based server here, so it could be HP, Dell or Nokia airframe or whatever. And then of course we are having a certain cache layer there, and then we are running these platform services on top of that. So these workflows. And of course Cloud Run is just a one workflow as such. Of course it's much more, but in theory it's just a one workflow. Like this real-time rig, it's a workflow. and if we are bringing there some online gaming server, it's just a one workflow. So that's why this kind of whole mobile edge transformation is very important, because now we can really start to bring there a different type of applications and workflows, and then decide where you would like to make this kind of local breakout, what type of programmability you are bringing there, and so forth, because now it's coming more agile, and those are just these microservices or workflows what you can then upload here and there where you need to have those in your network.
The example that you mentioned, the beam forming and the steering
Mm-hmm.
and the change, it's a real time.
Near real time, yes, yes.
It's very low latency.
Exactly.
Change with the end user of the beam.
Yeah.
So where do you place the rig for those type of?
It's a far edge. Yeah, because you like you mentioned, so this latency is critical on that use case. Yep.
One more question.
Yep.
So you optimize, look into situation in one cell, you optimize things like
Mhm.
beam or the user distribution.
Yes.
But then it will impact the cell design. So you will start to optimize it, and it will be a chain reaction. Do you think that there will be stability in the network, or there will be continuous optimization because of continuous change in every cell?
Yeah. Okay. Of course, this kind of fluctuation is a thing what we need to consider, especially when we are doing this type of group of beam optimization, and that's why it needs to happen in a wider area. So because of course this RAN intelligent controller is able to collect this information, each of those G node Bs in there. So we know that okay, there is no traffic, so I don't need to touch anything in there. But here I need to do this kind of optimization and so forth, because now it's happening on real time. So you're getting this feedback from radio, and then you're able to make these decisions. Yes.
Do you have such experience on a long term in an area that it is really getting some stability, or there is a continuous optimization effect?
I would say that we are quite early phase, but at least those trial results what we are having, really good. Yep. Last question. Yep.
Will there be a kind of app store where I can look at what's already available? Or do we
Yes, we are going to establish this kind of marketplace, but now we are having these first applications. This is this advanced traffic steering that is developed by Nokia. Then we are having this cell anomaly detection, and then we are having this group of beam optimization. And Joachim, do you remember? And yes, yes. Okay, thank you.